Okay, so now I'm going to go through exercise 225. This is something we would have done in class together. So side effects of Avandia. So we've got this drug, rosiglitazone, whatever. Is the R drug is the active ingredient in the controversial type 2 diabetes medicine Avandia. It has been linked to an increased risk of serious cardiovascular problems such as stroke, heart failure, and death. A common alternative treatment is the P drug. The active ingredient is a diabetes medicine called Actos. In a nationwide retrospective observational study of 227,571 Medicare beneficiaries age 65 or older, it was found that 2,593 of them used the R drug and 5,386 used the P drug, had serious cardiovascular problems. So it's summarized in the table. So cardiovascular problems, and then the R drug and the P drug. Okay. Determine if each of the following statements is true or false. If false, explain why. Be careful. The reasoning may be wrong, even if the statement's conclusion is correct. In such cases, the statement should be considered false. Okay, since more patients on the P drug have cardiovascular problems, we can conclude that the rate of cardiovascular problems for those on the P drug is higher. That's false. Oh, yeah, I'm going to change the, let's see. So that's false. All right. And then if false, explain why. Look at proportions. Yeah, right. So I'm not going to write that down. I just said it. All right. So the data suggests that the diabetic patients who are taking rosiglitazone are more likely to have a cardiovascular problem since the rate of infection for patients on this treatment, while it is only more likely to have cardiovascular problems since the ratio of incidence is just barely above the other one. It's inferring to the whole population when the numbers are really similar. So false. All right, the fact that the rate of incidence is higher in the R group proves that, yeah, it suggests, so never mind. Because the data suggests, then we'll put it as true, even though it could be a very small change. Okay, the fact that the rate of incidence is higher for the R drug proves, it does not prove. It does suggest, but does not prove. Okay, based on the information provided so far, we cannot tell if the difference between the rates of incidence is also true. So we can't tell, but it does suggest. Okay. What proportion of all patients had cardiovascular problems? Well, let's compute that. So let's get out our handy dandy calculator. Or maybe I could even put these in Excel. That might be even better. Okay. Let's make that smaller and bring that. I don't need that. Get out of here. Okay. I think I have all these tabs open when I was trying to figure out how to make that graph. All right, back to here. So I don't need that either. Okay. So let's enter in some numbers. So we've got R, P, yes, no, and then we've got 2593, and we've got 65000, and we've got 5386, and we've got 154,592, and then we can add those up like so. And look at that, our numbers match. And then we can drag that over. We can add this up like so. And stop it, please. Hey, my 6-year-old just having fun. All right, so Our numbers match up. Good. Now, we're for part B, what proportion of all patients had cardiovascular problems? So for part B, we have that's equal to this divided by that. Okay, so 3.5%. Could even make it a percentage here. Yeah, 3.5%. Okay, then if the type of treatment and having cardiovascular problem were independent, about how many patients in the R group would we expect to have cardiovascular problems? For answer C, the answer is the one right above. So if the two different drugs were independent, then we'd expect them to have, they both would have the same proportion, okay? If we investigate the relationship between outcome and treatment in the study using a randomization technique, while in reality we would carry out the simulations required for randomization using statistical software, suppose we actually simulate using index cards. In order to simulate, which states income independent of the treatment, we write whether or not each patient had cardiovascular problem on cards, shuffle all the cards together, then deal them into two groups of size 67,593 and 159,978. Who would have time for that though? We repeat the simulation 1,000 times, and each time record the number of people in the R group and in the with cardiovascular problems. So then we look at the relative frequency here, and it's there. Okay. Oh, right. So I answered incorrectly for C because it's asking how many people. So it's equal to this times the number of people. So 79, 79. No, it's equal to this times the number of people in the R group. So that's B4. No, D2. Yeah, 2369. Okay, and then we want to round it. Probably do a whole number. Yeah, 2370. Okay. Then, so 2370 is not far, that's in the normal area. So for part I, D part I, what are the claims being tested? The claims being tested is, that the null, or H0, is that the cardiovascular problems and choice of drug are independent. Independent, and HA, cardiovascular, I spelled it wrong up there, didn't I? Problems and choice of drug are dependent. All right, let's change the spelling. Cardiovascular. Okay, then compared to the number calculated in part B, which would provide more support for the alternative hypothesis, more or fewer patients with cardiovascular problems. Number calculated in part B, which would provide more support for the alternative hypothesis, more or fewer patients with cardiovascular problems. So the alternative hypothesis is that we would expect more. And then D3, what do the simulations suggest? That the simulation suggests that the difference, the measured difference, between groups is due to chance. We fail to reject the null hypothesis. Okay, and that's it for that. And so, finally, what are the steps of hypothesis test? You got to frame the research question in terms of null and alternative hypothesis. Collect data with observational study or experiment. The order of the step matters for the integrity of your test. Analyze the data, compute the p-value. Form a conclusion using the p-value to decide if your results are statistically significant. Write it in plain language. All right, that's it.